Class, in this video, we begin the discussion on section 4.2 in your textbook on the natural exponential function. Most of you are familiar with the number pi from your high school mathematics, your math you took in high school, right? Most of you know pi as the number 3.141, or pi being pi being equal to the value of pi to 3 decimal place being 3.141. Pi, in my estimation, is a miracle number of mathematics, and the reason that I think of it in that way is that if you take a circle, no matter how big or how small, and you take the circumference of the circle, right, which is the distance around the circle, and divide that circumference by its diameter, no matter how big or how small the circle is, that fraction, the circumference divided by the diameter, will always equal this number pi, 3.14159265358 to 12 decimal places. Well, we're going to be talking about another number in mathematics that in my estimation is a miracle number, and that is the number e. And the number e is the result of a sequence of numbers, and hopefully you've had some exposure to sequence of numbers in high school, but if not, right, we'll review it here for a second. So the number e comes from the sequence 1 plus 1 over n to the n. And n is represents the nth number in the sequence. So if n is equal to 1, we're talking about the first number in the sequence. If n is equal to 2, we're talking about the second number. N equals 3 for the third number in the sequence. N equals 10 for the 10th number in the sequence. And n equals 100 for the 100th number in the sequence. So to find the first number in the sequence, right, we put in 1 in for n in the formula, and we get the first number in the sequence is equal to 2. Then to get the second number in the sequence, we put in 2 in for n in the formula, and we get the second number in the sequence is 2.25. Similarly, the third number in the sequence, we put in 3 in for n up here, and we get the third number in the sequence is 2.37037. So we do the same thing for the 4th, 5th, 6th, 7th, 8th, 9th numbers in the sequence. For the 10th number in the sequence, we put 10 into the formula up here, and we get the 10th number in the sequence is 2.59374. We continue on in this fashion, and then until we get to the 100th number in the sequence, we put 100 in for n up here, and we find that the 100th number in the sequence is 2.70481. And you'll notice that as we go from 1 to the 100th number in the sequence, the numbers in the sequence are increasing, but the further out in the sequence we go, the less the rate at which they increase is slowing down. So over here in the table on the left, right, we have to find the 1000th number in the sequence. Right, we put 1000 in for n up here, and we find the 1000th number in the sequence is 2.71692. And then continuing on, we find that the 100,000th number in the sequence, putting 100,000 in for n up here, is 2.71827. Now look at these two numbers in the sequence. Though there's not much difference between the 1000th number in the sequence and the 100,000th number in the sequence. You can see that the difference is very small. And then we go out to the 1,000,000th number in the sequence, right? We put 1,000,000 in for n up here, and we find that the 1,000,000th number in the sequence is 2.71828. And you notice that there's essentially almost no difference between these two numbers. So what is happening is the further out we go out in the sequence, the closer the number is to a specific number on the real number line. And in mathematics, we say that the sequence of numbers is converging to a particular number on the real number line. And so if we were to keep doing this for the 1 billionth number and then the 1 trillionth number in the sequence, we would find that the sequence converges to this number on the real number line, this 2.7182818288459. And so that number in mathematics we label with the letter E. And so it is, in my opinion, a miracle number in mathematics that this sequence of numbers generated by this formula right here, right, or here, right, generated by this formula converges to a specific number on the real number line, and we call that number E. All right, so that leads us to the natural exponential function. So over here on the right is our definition of an exponential function from section 4.1. F of x equals a to the x is called an exponential function if a is a positive real number not equal to 1. So if a is a positive real number not equal to 1, then f of x equals a to the x is called an exponential function with a base of a. Right? That was section 4.1 material. Well, e equal to 2.71828, right? That's a positive number, not equal to 1. And so we can replace the a in our definition with the letter e, and we create what is called the natural exponential function. So e is such a special number in mathematics that we call the exponential function with the base of e, we call it the natural exponential function. So whenever you hear talk about the natural exponential function, we're talking about e to the x, okay? An exponential function with a base of e. So let's take a look at this example down here. Over here on the right is the graph of the natural exponential function f of x equals e to the x. You can see it's upward sloping, like some of the exponential functions that we graphed yesterday, right? It flattens out going to the left, but it rises rapidly to the right the larger the value of x is. So in this first example, right, f of x is equal to e to the x, the natural exponential function, and we want to evaluate that function at x equals 1. Well, we evaluate the same way we would any other function. We're going to put in 1 in for x up here, and we put in 1 in for x. We have e to the 1, and e to the 1 is just e to the 1 power is just equal to e, and e from up above is equal to 2.718 to 3 decimal places. To evaluate the function at x equals minus 5, we just put in minus 5 in for x up here, and we have e to the minus 5 power, and now you have to use your calculator. Your calculator should have an e to the x key on it, and you just put in minus 5 in for x, and you have e to the minus 5, and when you hit enter, you'll get 0.007. So e to the minus 5 power is equal to 0.007.